Okay, ladies and gentlemen, fellow tech enthusiasts, good afternoon, everyone. It's a great pleasure to welcome you all to. Can you hear me? Today's event. Yes, okay, that's good. Just got confirmation that we all can hear me. So, once again, I'm welcoming everyone to the Microsoft Build 2023 after party. It's my honor and pleasure to serve your moderator for this exciting event. Um, so, we intend to. Sorry, we've witnessed incredible innovations and groundbreaking technology and the power of collaboration that's fueled the Microsoft ecosystem. As we transition from this conference to this lively gathering, let us be well in the shared passion for technology, creativity, and the limitless possibilities that lies ahead. We have a couple of fantastic speakers today with us. I'll be sharing some of the knowledge with us today. And I'll urge every one of us to remain attentive and listen to them as they share from their experience. Confidently, at the end of it all, we'll all have a memorable experience. I would like to bring on our first speaker for today, Mr. Promise Fumachiku, who is a software engineer. You have the floor.
Thank you very much, Olumide. It's a pleasure once more, being on this forum and sharing as much knowledge as I can. So, yes, I'm happy to be here. And I'm hoping everyone is also happy to be here as well. It's a good one. Today happens to be the day we have chosen as a community, to discuss on the events that happened at the Microsoft Build, right? And of course, we termed it nothing but the Microsoft Build 2023 after party, right? And we have some interesting lineups for today. Yes, we have some interesting lineups for today, and we are hoping that you'll be able to um, relate with us as we talk about some of the things, some of the topics that were discussed during the Microsoft Build session, and also share some of the services that we feel would benefit your businesses. Even if you're a DevOps engineer, I feel like this is something you need to know, right? So today I will be speaking on introduction to Azure Kubernetes Service, which will be like I would call it an intro into the Kubernetes world, right? And of course, I'm going to be having other wonderful speakers today who are going to be on board with me. So please just stay tuned and enjoy as much as you can. So, like I said, I'm going to be taking this wonderful topic here on introduction to Azure Kubernetes Service. Right. Um, I'm sure you would have been wondering, maybe you're one of those who have been in a situation where you're like, oh, what is really this Azure Kubernetes service? How do we gain from it? How do we benefit from it? Or what is it really about? And I'm here to give you some insight into what the service is really about. Yes. So in this particular session, I want to be looking at what Azure Kubernetes Service is. Also, we would like to consider, what are the considerations you look at when working with Azure Kubernetes Service. And also, if you would like to, do some design or make some workloads on your cluster, how is the best way, to be able to make this design, making use of, a container solution. I hope we all know that Azure Kubernetes Service itself makes use of, the container solution. That is one of the things I would say one of the things you would notice that the Kubernetes service itself runs under, right? So, I mean, the backbone, or what would I say, one of the infrastructures, or let me say, smallest units that enables your Azure Kubernetes service to work is the containers. And we'll be taking some closer look into them, right? All right, proceeding. I want to say these questions came through my mind while I was actually talking about, or preparing towards this particular session. To be able to explain to you what this is, I feel that there are questions we need to answer. You understand? And one of the things that come to my mind is, before you say you want to run a Kubernetes service, do you understand what happens underneath of it? What are those things that enable the Kubernetes service to function? And today we'll be looking at some of these questions like, what is a container? Why do we use a container? What is container management? And then this will then lead us into what is actually Kubernetes. And then Kubernetes on itself will now tell us, we now go further to understand what is Azure Kubernetes service. So there's the Kubernetes platform on its own, and then there's the Azure Kubernetes service. We then get to understand how Azure Kubernetes service works. For instance, we'll try to see if we can get a cluster running. We'll see how to create a cluster and how that also works. And then we'll proceed to how workloads are developed and deployed on the AKS cluster. So we'll try to see if we'll be able to log into the cluster and check to see, how to just do a sample deployment into the cluster. And then we can move over to the bridging of Kubernetes, basically just how to share, or how to what's the word, communicate with your pods running on your Kubernetes cluster from your host machine. And then we'll take a look at deployment center, Azure service integration, and then further down the line. But first, let's go. What is a container? I'm sure you're wondering. You've heard the name several couple of times, and you're wondering, what does this mean? A container on its own is an atomic unit of software that packages up code, dependencies, and configuration for a specific application. In other words, what you use a container, or what a container is like an environment that has helped you to gather everything you will need for your application to run smoothly. Now, why do we use containers? What is the main purpose why we use containers? Right? One of the main purpose why we use containers is because, one, it's immutable. When I say containers and immutable, you may be asking, what do I mean? What I mean by that is that the container itself, is a very lightweight package, right? Which you can run on any environment and will give you the same behavior. That's the way the container is structured, right? You can test it if you have the same libraries, the same image, everything inside of your container, and you move them between different environments, they will behave the same way. Why? Because they are provided with everything that is needed of them to run. Another thing again, why we make use of container, is the fact that it is lightweight. Imagine you are packaging an application, and that application itself is not so heavy on your probably your virtual machine or your cluster, right? With just a small amount of size, you can have something that can be able to carry out all the functions of your application, and all the functions working properly. And then, even if you want to scale the load which will be assigned to these containers, you can as well scale the containers to be able to take on more loads, right? So it's lightweight, and that is one of the beautiful features why we make use of containers. Another reason why we make use of containers, because it is easier to start up. It's very easy. It takes a few couple of seconds to start up a container, and then you have everything running for you. You understand? So these are some of the reasons why people make use of containers. So the first reason I talked of is one, it is what? Immutable. Two, it is lightweight. And three, it has a very fast startup rate. Now, what is container management? When we are talking about container management, what we are actually looking at is the life cycle process of a container. When I mean the life cycle process, I'm saying from the point where you are starting up the container to the point where you are stopping the container, or the point where you want to remove or destroy the container. That is all we call the processes that involve or that the container management entails. Deploying, updating the container, monitoring the container, removing the containers. A lot of challenges coming to the process. But then with container management processes, you are able to manage how these containers are starting up, how they are stopping, how they are being removed, or how they are being updated. So that is what we mean by container management. Another thing you may be asking is, you know, this Kubernetes itself, what is it really? So a brief history on Kubernetes is actually an open source platform, right? For basically automating deployments. You could also use them for scaling your deployment, management of your containerized workloads. So it's an environment or a very portable platform, right? That gives you the ability to do deployment in small scale and also in large scale. Now, because of the fact that this service itself, right, it's a wonderful service, right? The Kubernetes itself is also a wonderful service. You understand? Microsoft now comes into the picture to simplify the process for you. So if you were to deploy a Kubernetes cluster, right? I mean, you would have to bring in a couple of servers, run some commands to make one the master and make the other the slave nodes, right? So you can be able to log into the master, control deployment from the master, and all of that. That's the native way of setting up your Kubernetes cluster, right? But then Microsoft decided to come into the process to simplify all of that for you. And that's why we have Azure Kubernetes Service. Right now, what Azure Kubernetes Service is just basically a managed it's a managed platform by Kubernetes by Microsoft. It helps it is a platform Microsoft built, right, that incorporates the Kubernetes service itself, but then they have simplified some processes for you. You would actually see what I'm saying when we are actually deploying a Kubernetes cluster. Hopefully, yeah, we should be able to deploy one and then see how the workloads go. So, like I said, Azure Kubernetes itself is Microsoft coming in to help simplify the process of setting up your Kubernetes cluster, so that in a couple of minutes you could have a cluster running that helps you, automate your workloads and all of those things. Right. Another thing now we will look at, or where we'll be heading to next, would be how does Azure Kubernetes Service work? To be able to show you how Azure Kubernetes Service work, I'll try to see if I can quickly explain, the process of creating a Kubernetes cluster, and then we'll connect to one Kubernetes cluster and see how it runs and what to do. Yes. So let me do this. Yes. Yes. Okay. Just a minute. All right. So I believe you should be able to see my browser. Yes. I believe you should be able to see my browser right now. So basically what I just did was to go over to portal.azure.com. right? And then, since I'm already authenticated, it's easier for me to, just log in, right? And then I can proceed to Kubernetes service. If you are wondering where Kubernetes service is, you can as well just search it up here, Kubernetes service, right? So you can see this. Once you click on this, it gives you the same window. And then now you can click on the create button to create a Kubernetes cluster. Now, once you want to create a Kubernetes cluster, there are just a bit of some few questions that you need to answer before the cluster will be created. So let's see if we can do this in a couple of minutes. So I'm going to create a new resource group right now, and I'll call that resource group MS Build. It's asking what kind of environment do I cluster preset configuration. So I will just make use of the standard one. What is the cluster name? I can say MS Build cluster. I can make use of the US East region, zone 1, 2, 3, the standard AKA pricing, and all of these settings you can leave as default. And I'm also doing the same thing. The node count, I want to just do probably a 3 cluster node count, right? Yeah, so that the node count can range between minimum of 3 to a maximum of 5, right? And then on the next one, it just talks about the agent pool. The agent pool is like what type of OS do you want to have in your Kubernetes cluster. That's what agent pool is all about, right? So I chose Linux for that, and the rest of these functions I can leave them as defaults, right? All of this I can leave them as defaults. Yes, I can leave all of this as defaults. Oh, someone says my screen is blurred. Okay, well, let's just see. I hope it should be a bit better now. Just a minute. So you can see that with this is running a final validation, and then once the validation is completed, it gives me the go ahead to create the cluster. So if you can see this in a couple of minutes, right, I'm able to set up my Kubernetes cluster. That is the beauty of what Microsoft has done for us. And that's why it's called the Azure Kubernetes Service. The reason is that they have simplified the process so that you don't need to start bringing 2 or more servers together. You don't need to start running a couple of commands and all of those things. All of this can be done simply with just few clicks, and then your cluster is up and running. So you can see here the cluster right now is coming up, right? You can see it's coming up a bit. So let's just give it some time while the cluster comes up. So while the cluster is coming up, I will just see if I can move on to 1 or 2 sessions, and then we can come back to the cluster and be done in a bit. All right, so we've talked about I've just shown you right now, how the service works and how you can actually create a Kubernetes cluster in the Azure environment. And then now, in terms of the workload, what do we mean by the workload? The workload itself is what exactly are you deploying? What application are you deploying in your Kubernetes cluster? That's what the workload is talking about, right? Do you have a specific application you like to deploy? Do you have some certain services you like to make use of? That is basically what the workload is talking about. Now, building a bridge to your Kubernetes cluster, is as simple as just saying, how do you connect from your local machine to your cluster? Remember, these clusters are hosted in Azure. But Kubernetes provides a form of bridge which you can set up between your local system to communicate to your Kubernetes clusters. Check what's happening within the pods, checking the logs, and in fact, you'll be amazed at how all of this is working. And then for the deployment center, this is like a just the same way we logged into Azure. We went to a place where you can actually create your cluster. For the deployment cluster, there's a service Azure has, which is a DevOps service, right? The If you go to the Azure DevOps site, you can actually build a pipeline that helps you to deploy this with the click of a button. So basically, what you're doing is writing some codes at the back end that each time you click on that button and say deploy, is going to set up all this process for you. So you don't need to go to the portal and say, okay, I want this, I want that. No, all of that will be done by the all of that will be done by the Azure DevOps pipeline, which you would have deployed. So let's take some time to look at the cluster. Let's see if the cluster is ready. Okay, checking this, I see the cluster is not ready yet, but let's go back to our slide then. Now, I was trying to explain to you the workloads. You see, here is how the workloads are developed and deployed to the AKS cluster. So by default, if you are a dev guy or if you are a DevOps guy, you know one of the tools we use is your VS Code, your Visual Studio Code, right? So let's say you have your code in your code written in your Visual Studio application, you push it to your Azure pipeline, right? And then from your Azure pipeline, you can then decide to create your containers, right? With your images stored in Azure Container Registry, right? And then from here, your Docker container will be the, let me say, like the underlying body which is hosting your pods. And then here you can see here is your production cluster. But then if you look at this, we have the bridges. The bridges are what connects the pods together, in the Azure environment, and also what helps you communicate with your cluster. That's why you have the bridges here. And then from here, you can have like a monitor which you can use to monitor your application. So with this, you are able to, from scratch, write the code, to deploy your Azure Kubernetes cluster, right? Making use of your pipeline, deploying your images, your containers, and then you are good to go. So basically, this diagram just explains the process which is used to be able to develop and deploy applications to the Kubernetes cluster. Right. So let me just take a quick look at the Kubernetes cluster, and then we can see it. Oh, already. So now you can see that the container is set. You can see that the cluster is set, and this is basically what the cluster looks like. I will just show you a brief run through, and then I'll ask for questions, and then we can move over to the next session for today. So you can see, just looking at that, you see we have one node pool configured for this cluster, right? As you can see on the screen, you see we have one agent node pool here, but behind this node pool, we have this amount of nodes. Yes. So if you take a look, you can see all the services that were deployed to ensure that this Kubernetes cluster is in functioning properly. One of the service is you can see this is the Kubernetes load balancer that helps to communicate between the various nodes. You can see this is the public IP, the virtual network, the virtual machine scale set, the route table, the network security group, and then we also have a managed identity which helps us communicate with the Kubernetes cluster. So sorry, I couldn't really do all of the labs to show this, but this is just an intro into the Kubernetes service, right? And down the line, while we continue with this session, I'm sure some other speakers will also give you deeper insights on how you make use of your Kubernetes cluster. So at this point, I would just like to ask, are there any questions? Do we have any questions? Do we have any questions? Yes, hello Roland. Do you have any questions for me? Sorry, I can't hear you, Roland. Looks like the audio is a bit down on your end. Um,
Oh, can
okay.
you hear me now?
Yes. Your audio is up now.
Oh, okay. Thank you so much
Yes.
for such an insightful session. Bro, the time was quite short. We just have to
Yes.
manage so that we can accommodate other speakers.
Yes.
So we have a question. Is there any difference between Docker and Kubernetes?
So your Kubernetes actually makes use of the Docker itself, right? While the Docker is the containerized um while the Docker platform is like a containerized platform that holds your various Docker images and containers, your Kubernetes platform is like a platform. It doesn't, your Kubernetes platform holds more than just the Docker itself, right? It helps you administer and manage the various containers within your Kubernetes cluster. So that's one basic difference, right? Also, there are other what would I call them, containerized platforms to make use of. Kubernetes Azure Kubernetes Service is just one of those containerized platform that is a managed service created by Microsoft to ensure that your platform is running smooth. Okay, one says here, what are the key benefits using Azure Kubernetes service for container orchestration and deployment? One, well, you actually set in about 5 up and running when you are making use of Azure Kubernetes service. So that's one of the beautiful um, um, positive impacts of making or benefits of making use of the Azure Kubernetes service, right? And you can as well at the same time do a lot of scale ups with for your nodes, because the platform itself make use of the virtual machine skill set. You can either scale out or scale in at any given time, right? And this helps to save you costs, so you don't bother about running so much costs on your nodes. So those are some of the benefits for your Kubernetes service. All right, I think at this time, we can move on to the next session for today. So I'll be calling on Olumide to come on and then introduce the next speaker. Yeah, Olumide, Roland,
Okay,
are you guys there?
yes, I'm
Oh,
here. Can you hear me?
yes, I can
So
hear you.
that was a beautiful lecture from you. I learned a lot, and I'm sure everybody else on this call also learned a lot. So we'll be having our next speaker, the person of Torilope Adeleke.
Oh, the
Um,
next speaker is
okay,
Imom.
Imam. Okay. Sorry about that. So we'll be having our next speaker in the person of Imam. Imam is one person that I really look up to because whenever I speak, I know it's so much knowledge to be gained from his experience. So I'm sure that we would also learn a lot from him today. So Mr. Imam, you have the floor, sir.
Okay, thank you very much. Can you confirm my audio if I'm
Yes, I
audible
can
enough?
hear you very well. I can
All
hear you.
right. So
Great.
without wasting much of our time, I'm going to jump in already. I promise has already done justice by taking us through the basics of Azure Kubernetes Service. And trust me, Azure Kubernetes Service is actually one of the best platforms to use to manage your clusters and pods and all that, and containers as well. So today, the topic I'm going to be talking on is just going to be a kind of consolidating on where promise stop by extending it to some of the things you need to do in order to secure some sensitive data in your container, within your cluster, a kind of environment. So I'll be talking about on managed application configuration and secret in Azure Kubernetes Service. So as we all know that Azure Kubernetes Service is a managed component of the open source Kubernetes. We have the open source generally managed by the Kubernetes itself. Kubernetes is owned by Google, so it's something that now Azure, Microsoft is having this as their own managed platform. Why do they have it? Just to save you, the user, you and I, the time of having to manage clusters on your own. Kubernetes is very bulky, so it's not something that you should easily manage it like that. So now the agenda will be that we're going to be looking at the introduction aspect of this particular track. Then we move down to some prerequisites for you to be able to follow along. And now, if you have your laptop with you, better, because we're going to do some little demo and all that. Then you will need to understand Kubernetes secrets and move on to demonstrate some how to securely store variables in secrets. Then I'll provide some links for you to learn further in the course of learning. So now what we have on the screen is a scenario that you could come across. If assuming like imagine if you work for a freight company that transport goods all over the world by using ships. The operation department uses a small system that tracks where all the company's ships are docked. These company ships can be likened to sensitive data. Due to staff increases, this system is being moved to Azure Kubernetes Service to be able to, for efficient management. However, the security team noted some flaws in the application configuration. Some configuration were hard-coded in the app, and some sensitive values like connection strings were left as plain text. You can imagine that's where Kubernetes secret comes in. They require changes before this application could be deployed to production. So what do you need to do? So that's where we move down to what secret is. And now you get to some of the prerequisites, which is familiarize, you must have some basic knowledge of Kubernetes, just as Promise has taken us through. Then you need to have active Azure subscription. You need to also have the ability to use the Azure CLI. So moving down to this slide, we have understand Kubernetes secret. Now, a secret is an object that contains a small amount of sensitive data, such as password, a token, or a key. This is taken from a Kubernetes official document. Then for Microsoft Learn, provided by Microsoft Azure, they see secret as a type of resource present in Kubernetes that lets you store sensitive information in a safer way than using them in plain text format in pods and deployment. That is Microsoft Learn. Then going deeper in our own way, so a secret can be seen as something that contains a small amount of data that are designed to store password and sensitive data for your clusters. Now, such information might otherwise be, you can maybe store them in a pod, specifically, or in a container image. Using a secret means that you don't need to include confidential data in your application code. If you include application data in your application code, it's totally dangerous and it's not recommended in the production environment because anything can happen. So that's where secret comes in. And secrets are created using base64 encoding or plain text. You can use plain text, meaning if you use plain text to create your secret, Kubernetes will notice it when you're defining your YAML file, which we are going to come to that. You need to state it instead of putting it as string data. You need to define it as data. So Kubernetes having seen that will automatically encrypt and turn it to secret for you. So that is what some of the things you need to know. Please, I'll be taking questions along because of our time. Then we have some types of secret to explain. Then types of secret, we have Kubernetes.io and service account token. Then we also have Kubernetes.basic auth. We also have Kubernetes TLS, transport layers security. Then some of this, the account token, service account token in Kubernetes secret defines a secret account token. Automatically, it's automatically created when a new service account is created. In this one, when a new service account is created within your Kubernetes environment, it will automatically create it. Then for basic auth, it's just a credential for maybe basic authentication that you need to set up within your cluster or your ports, something like that. So now we have the TLL, which is transport layer security. Then we have it to be client server data. This is used over an HTTPS connection, server connection, maybe via browsing, if you are using a kind of, maybe when you are applying a kind of ingress resources, for example, that is when you can make use of this type of secret. So now we also have, okay, there's no question so far. So let's move on. So we are going to talk about creating a secret. So for you to create a secret, there are some things you need to do. How are they created? How can you create this secret and use it? So now secrets are mounted as files in a volume and containers inside a pod or deployment. So another one is it is referenced as an environment variable in the pod or deployment specification. It is also used by the kubelet when pulling images. Some of these components of Kubernetes, I would advise you go to Kubernetes official documentation, the basics, the beginning, kind of the beginner's guide on Kubernetes official. I should drop the link for us so that you get to understand some of the, I will drop the link, I'll find out the link and drop before the end of this presentation. So you need to understand some of the kubelets when pulling images from private registries via image pull secret key in the port specification. That comes in when you are defining the port specification in your YAML file. So now, having said that, we move down to how this secret can also be created within the YAML file already. So now you can see that from the screen, we have a secret can be created like any other Kubernetes resource. Either you use YAML manifest file or kubectl command. Kubectl command is one of the command line to use in managing Kubernetes cluster. You can like, I will drop the official link for you to go there and check. So now, if you look at it, we have the secret specification is as follow as we have it on the screen. So now, for this secret, you will need to encode the values before creating the secret. If you look at it, the data is where the key comes in. The key is in base64 format. Base64 is one of the format of storing secrets or credentials, managing keys and all that. So if you want to create secret in plain text, just as I explained today earlier, if you want to create it in plain text value and let Kubernetes encode it automatically, you need to use what's called the string data. Yes, apologies, it's string data, not data. With this kind of format, Kubernetes will just encode the secret for you by itself. But if you want to encode it before you pass it, you use this defined data instead of string data here. I don't know if you have any question on that. So we move down to how to update secret. Updating secret is like a secret update. Now it's they change all secret that are mounted as volume inside the port are automatically updated once their value is changed. Once you change any value, you don't need to do a kind of manual update or process of getting things done. It just will automatically update itself. So now we move down to it's just a brief slide. We don't really have much time, so that is why we have this short slide. So now I will brush through some knowledge checks question, which I think I will drop this question for us on the chat, so you'll be able to answer them. And just to test your knowledge, I will drop one question for you at the end of this section for you to win a prize from me directly, not from the community. So now we need to jump right into demo section. And because we need to see how we can create a secret and pass it into our backend application and all that. So without wasting much of our time, let us launch to our Azure portal and get started as soon as possible. So I'm right into my Azure portal. To save time, I've already defined some of my configuration code, which we are going to use because we don't have much time to write them one after the other. So now we are going to launch Azure Cloud Shell because we don't have time to go through the portal to creating resources one after the other. So what we are going to create first is the resource group. We understand that every resource is stored on a resource group. And with that, we have written this to automate the process of deploying a resource group as soon as possible. So we're just going to copy this and paste. The name of the resource group is, I already stated the cluster manager name. Then the name of the resource group is RG Ship Manager. Then it will create within the location being tied to this particular script. So we have our resource group created. Let me expand this. So having done that, the next resource to create will be let me clear the screen to avoid clustering it. The next resource to create will be the Kubernetes cluster, Azure AKS cluster. This cluster will enable, just as promised, as explained before, is launched based on virtual machine scale sets. As you can see, I'm using the VM size is a standard B2 class. So and I will tie to that resource group name and the cluster name that was defined in the initial script. So I'll just run it. It might take about 3 minutes for a cluster to be launched. So while this cluster is being launched, let's go back and see. We are talking about secrets. Now, the question I was having is, within 20 minutes, if you can answer, anybody that answer will have about 20 gigabytes of data to support your data. So if secret is for storing sensitive data when it comes to Kubernetes, what then can be used to store plain in non-sensitive data in Kubernetes? What can we use to store non-sensitive data in Kubernetes if we are using secret for storing sensitive data? I don't expect Googling this. Maybe I should set up a timer for this, about 10 seconds. 20 seconds, sorry. So if you have, let me reset this to start afresh. Let's say we have the timer running, 20 seconds. If you can answer that, is the answer, what are the use cases? Is there a price for answering? Yes, of course, you get 20 gig data for any network you use. We said, okay, let's start afresh. Let's reset this timer. 20 seconds. What can we use to store non-sensitive data in Kubernetes environment? If you use secret for sensitive data, what can you use for non-sensitive data? Timer started. I won't go back on this. So while that is going on, let's go back and check this thing is still running. The timer is always gone. It's almost gone. Oh, it's gone. So we are not getting it. Nobody attempt that. Okay, maybe another question will come before we go. That might be a little bit difficult for us. But if you make your research, certainly you should know that. So part of the things we are going to create, remember, secret is used for storing non-sensitive data, just to ensure it's sensitive data like application and password, things that are not meant to be publicly exposed, to avoid hackers being hacked into it and all that. So while this is running, we just need to see how to create the secret. And remember, secret is stored in a base 64 format. So that's what you need to, the basic thing you need to know about secret in Kubernetes. So I'm going to do a question from test your knowledge question that I have. Let me. Uh, why do we why do we have why are Kubernetes secret several values? That's the question I have. So the option that has been provided, that is A to C. Remember, we are waiting for this stuff to create. So the option we've been provided is, let me go back to the slide. One is, okay, if you have, why do we have, why are Kubernetes secret safer than plain text? So the options are, one, A is because they encrypt the data, because they don't let sensitive information open to all users, concealing them in a workload. They store the information elsewhere. So other questions there is, how can you use secrets in an application? I'm seeing SSD or SSD. This is a storage. You talk about hard disk drive, solid Franca. Emmanuel got it right. This one, there's no price because this is cheap. Sorry, there's no price for this. So how can secret be stored? Okay, and that, who said A is number one? A, Adeni Damilola said A for question one. Okay, so Emmanuel got it right. Instead of wasting our time, let's go to question two. While that is done, let's check if our deployment, if our cluster has been created. Okay, it's been created. So to create a cluster, I'm going to drop the code for us at your spare time when you have nothing to do, when you are trying to study. You make use of the code and see how it actually works. We might not have the luxuries of time to do it as in one after the other. So what we need to do now is to retrieve the administrative configuration key that we will use later in the course of deploying the application. Then to retrieve this, we will run the SZAKS get credential command. We specify the cluster name, which was tied to this to the script we run earlier. Then specify the resource group. So we are going to get the key and keep it for, we're going to copy this for a later use in the course of this section. Sorry. So let's quickly get that. Maybe there's a typo error there. Get this already exists in your config file. Yes, let's. Sorry. So now, I think that we need to get the key because that's what we use to continue in the deployment. Already exists. Okay, so let's jump on and go to creating the application. let's check if that cluster actually created by going to resource group. Let's check the subscription of this. So the time is almost up. I think I have, okay, Roland, my time, what is remaining in my time? I will be fast. I'm almost done. So we have the resource group. Let's go to resource group first. Okay, this is the resources we created. My time is up. I thought I started, is it? Okay, my time is up. All right, no problem. So I will provide the code for each participant to go home and practice, and also I have some links for you to learn further, for further learning. Let me bring that up and provide that for you. So the link is right on the screen. I will paste them on the chat for you to study more. And if you have any question, you can always reach out to me or any members of the community. Remember that I did not answer the question I was asking, if what's called, if a secret is used in storing sensitive data in Kubernetes, then what is used in storing non-sensitive data is config maps. So that's another concept you need to read. In the link I pasted on the read more link contain some links to learn more on config maps and also enhance your application and all that. So thank you very much for your time, and we actually have a short time. So someone, okay, Roland, you're up. Okay.
Okay, Imo, thank you so much.
You're welcome.
Yeah, thank you. It was an amazing time with you, and we look forward to always having more sessions with you. So,
Thank you.
without wasting much of our time, I'd like to bring on our next speaker in the person of Tolu Lope. Hello.
Hi, Roland. Hi. Hi, everyone.
We are fine. How are you doing?
I'm okay. I'm okay. And you?
It's good to have you.
Thank you.
Okay. So, Tolu is our next speaker. Without wasting much of our time, so I'd just like to give her the center stage.
Thank you. Thank you so much, Roland. So, can I go ahead and present my screen?
Yeah.
Okay. All right. Thank you. Yes. So, please let me know if you can see my screen. Okay. Yes. Hi, everyone. Good afternoon. How is your day going? And welcome to the after party. And this is the Microsoft Azure Nigerian community. And yes, my topic is on AI. So a quick question, everyone. Emma Franca has a request if you can place the links on the chat. She wants the link. Okay, there you go, Franca. So I have a question for everyone. If you maybe you're in a discussion with a friend or a family member, and then the individual is talking about AI, what comes to your mind? If I can have one person or one or two individual just say what comes to your mind. I think there's a very popular one among us nowadays that we mostly use every day when it comes to AI, especially if you're, in the business of 9 to 5. robots taking over the world. Yes, thank you, thank you, thank you, thank you so much, Joseph. And yes, for me, I'll say when I'm thinking about AI, apart from robots that are actually taking over the world, I think about, Chat GPT, what we use daily. Exactly. Thank you, Raphael. Thank you, Chat GPT. That what first thing that actually comes to my mind, because that is actually a lifesaver these days. So when it comes to AI, where does Microsoft Azure, where does Microsoft comes in when we're talking about AI? So before we get started, oh, I can't see my screen clearly. Okay, before we get started, right? What is AI? What is AI? AI actually, according to Microsoft Azure, AI is that software. AI is that software that actually enables us to. AI is that tool, sorry, that actually enables us to build amazing software like, robots. We can even communicate. We have ChatGPT that can do as much as write your content, write a formal letter on your behalf, answer, questions. Before we make use of Google, but no, when it comes to knowing things, knowing about different aspects of business life, I really go search on Google nowadays. I just go ahead and ask ChatGPT, tell me about this, give me information about this, and yes, I have my answer. So AI is that development, like where the future is right now. So it enables us to build amazing software that can improve healthcare. Yes. Enables us to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experience, and even save the planet. The amazing thing about AI is when I see a lot of information, even on professional setting, let's say like LinkedIn, I can tell if that individual actually, use AI in writing that content, because I'm like, are you telling me you can think this deep? That is how far AI is going nowadays. So simply speaking, let's just define AI here. AI is the creation of software that initiates human behavior and capabilities. So when we talk about AI, there are some things that actually go into work. And I think the most prominent one, the one in which every one of us know nowadays, is machine learning. So apart from machine learning, there are a lot of things that are actually working when it comes to AI, is development and all. But machine learning is the most common one. So we are going to like speak briefly on each of these. Like the topic says, we are just getting started. AI itself is large, so broad. We're just going to touch. And if you're preparing for Microsoft AI fundamentals, I think I'll be touching on some of these things that would definitely come when you're taking the certification, when you're taking the exam for that certification. So if you're an individual is preparing for the Microsoft Azure AI fundamentals, then this is a good place for you. So let's talk about machine learning. Machine learning is often the foundation for an AI system and is the way we teach a computer model to make predictions and draw conclusions from data. So, and okay, let me just say this. When it comes to AI, we think, okay, maybe programmers or maybe developers. But then when it comes to working with AI, we have a lot of data scientists, because AI make use of data a lot, makes use of data a lot, and we are going to touch that very soon. So I don't know if you've heard about the anomaly detection. So the anomaly detection, when it comes to AI, this aspect is used to detect errors or maybe an unusual activity in a system. Let's say there is an error while building a particular software. This is what actually helps detect that. Okay, so there's an error in this, and this should take place to cancel that error. So when you're in that system, you know that this is what is happening. This is what is detecting that. This is what we need to do to erase that. So frankly speaking, or let me say AI speaking, that is anomaly detection. If you're in that space, then you can, maybe this is where I want to focus on. This is where I want to focus on. Then you would know maybe you're going to focus on that aspect. So computer vision, there are some people who actually I think I've spoken with an individual who is working on something that has to do with AI. And then while I was, preparing for this computer vision actually, like broaden my mindset on what the conversation I had with that individual previously. So computer vision is the capability of a software to interpret the world visually through cameras, video, and images. And yes, we see it day to day with, let's say you're playing a video game, you would come across this a lot. Then we have natural language processing, also known as NLP, is the capability for your computer to interpret written or spoken language and respond in kind. I think we see this daily. Let's say ChatGPT, for example, and then we have some other softwares and applications that actually work with this. And then most especially when you're in the process of building your robots, just like Roland said the other time. So knowledge mining, the capability to extract information from large volumes of unstructured data to create a knowledge store. We'll talk about that. We'll talk about that later. So let's talk about machine learning. Let's understand machine learning. Like I said earlier, machine learning is the foundation for most AI solutions. That is why it is the most popular, because you have to start with that. That is why when we're talking of AI, the first thing we are going to talk about is machine learning, because it is that foundation, is the very basic of, solutions when it comes to AI. So like I said earlier, I think I said this earlier, in today's world, we create huge volumes of data as we go about our daily lives, like from our text message to emails to maybe street lights or traffic light readings, to your NEPA bill, to your water bill. A lot of data goes daily and we don't know. So from your text message to your emails to your social media posts to everything we do, we generate a lot, like a massive amount of information. So what do data scientists do with this data? So data scientists use this data to train machine learning models that can make predictions and inferences based on the relationship. So that is why it is easy for you to like type a question on ChatGPT and you get your answer, because a lot has gone into it to train ChatGPT on how to, you know, answer to your request. You can even give a scenario and tell ChatGPT, okay, I am interviewing for this position. Give me a scenario give me like a feedback and it creates it. That is because of the amount of data that has gone into it to train ChatGPT to be able to, act like you, respond, not act, like respond like you, create a scenario, even though ChatGPT have never been in such scenario, it has been trained to do so using data. So when it comes to Microsoft Azure, where does when it comes to machine learning, where does Microsoft Azure comes in? So Microsoft Azure provides the Azure Machine Learning Service, which is a cloud based platform for creating, managing, and publishing machine learning models. Azure Machine Learning provides the capability or the it actually provides the features or the capabilities that we see today, especially when you're making use of the Azure Machine Learning service. So Azure Machine Learning provides the following features and capabilities. So we are stating some of the features and what can they do or how do they come in when it comes to machine learning in Microsoft Azure. So the first one is the automated machine learning. So even from the word automation, we all know we should have actually grab what it is all about. So these features enables non-expert to quickly create an effective machine learning model from data because it is automated already. You can easily do it. You can easily create, even though you are not an expert in it. It is already like trained, it has been done, it is automated already. So it enables non-expert to quickly create an effective machine learning model from data. So another feature we're going to talk about is the Azure Machine Learning Designer. If you're like a product designer or maybe a graphic designer and you want to go into AI, I think you can actually look into this aspect. You can focus on this feature. So a graphic interface enabling no-code development of machine learning solutions. A graphical interface enabling no-code development of machine learning solutions. And when you're designing, definitely is no code. Another feature is data and compute management. Data and compute. Please note that data and compute. So cloud-based data storage and compute resources that professional data scientists can use to run data experiment code at scale. Cloud-based data storage and computer resources that professional data scientists can use to run experiment code at scale. So if data scientists want to do something massively, run it massively at scale, large, then they make use of this feature, the data and compute management. So pipelines, data scientists, software engineers, these are the people that actually make use of this feature. So one other aspect is, like I stated earlier, anomaly detection. So I think the reason why I place this is so we can understand it. Even by reading this paragraph, you'll be able to understand this. So imagine you're creating a software system to monitor credit card transaction and detect unusual usage patterns. Fraud. And then your, let's say your bank statement or your card statement, then you notice something is not right. You keep getting, some transactions that are not right, or an application that tracks activity, maybe during a production. So these are the scenarios, these are things that actually happen. And then, let's say, I'm not sure if we really have it in Nigeria, but then maybe you're watching a movie and then you they get to call, the fraud experts and all that. They make use of this, the anomaly detection. So these are the people that actually detect what is this feature. This department actually detects what, if there's something going on, something is wrong somewhere. This is, then they make use of this. I don't even know if anyone is following. Like, do you guys understand? Please, if you need me to go back somewhere, even though I don't have much time, please let me know. So in Microsoft Azure, the anomaly detector service provides an application programming, like an API that developers can use to create detection solutions. So that is where Microsoft Azure comes in. So natural language processing, thank you. Natural language processing, NLP, is that area that deals with creating software that understand written and spoken languages. Like, you can be speaking in, I think Instagram use that, whereby it will, maybe someone comments on your post with Chinese or a language that you don't understand, and then you see something like C translation. That is this guy working. So, or maybe you're speaking in a different language and then it's translating it to English so you can understand. So yes, that is where NLP comes in. I don't have much time. So these are the services and these are what they do. I think I can share the slides later. These are the services when it comes to NLP in Microsoft Azure, and these are what they do. These are the capabilities. These are what they actually do. AI is broad, very, very broad. So knowledge mining makes use of this core service, the Azure Cognitive Service. Azure Cognitive Search. Azure Cognitive Search itself is very large. Like, understanding this is very, very large. So knowledge mining actually helps us understand and making use of this core service, making use of this core solution and the Azure Cognitive Search. So if you want to understand where knowledge mining comes in, you need to first understand this Azure Cognitive Search. So knowledge mining is used to describe solutions that involves extracting information from large volumes on like data that are not mined already. So if you want to understand knowledge mining, you need to understand this first. I think maybe next time we'll have time to talk about all this. And there's nothing that has a positive aspect that does not have its own disadvantage. So AI might be great, absolutely great, but there are some challenges and risks that has to do with AI. So some of them are, errors. When you have error in something, how deep those errors can go. Maybe some data could be exposed, and this actually, I think, mostly the disadvantage and the risk that comes with it is those in the medical line. You can't expose their data. So some solutions may work for me, but definitely may not work for you. So these are some of the challenges and risks that has to do with AI. So if you're preparing for the Azure Microsoft Azure AI Fundamental, I think you can go for it. If you're currently on the Cloud Skill Challenge, then you would have come across one or two of my slide. So yes, AI is, way to go. AI is absolutely great, and AI is actually the future now. So please go on and learn more about AI, and then come in and work on one of two of the services that AI render. Thank you so much. Thank you for joining. If you have questions, you can drop it and then I'll answer on the chat. Thank you. Thank you, Roland. Thank you. I'm done here. Yes, I'm done here. Roland Damilare, I'm done here. Okay. Yes, Mr. Raphael. Can you hear me?
Thank you for a wonderful session, Tolu. We have enjoyed learning about AI and all the beautiful things that we should take note of. And I'm sure that a lot of people here are about to write the certification. So you have motivated them on how they should get started. Thank you, Tolu. We appreciate. So, ladies and gentlemen, I'm going to be taking over from Tolu. I don't know if I have, I'm supposed to have a break, but I'm very excited to come and tell you about the next topic. So I'm going to prepare my slide. Okay, I think I should share my screen. There are a lot of distractions. Let me close and share my screen. Just give me a minute. I'll be with you soon, and we're gonna have fun talking about Azure functions and serverless. Okay, just give me a minute or two, and yeah, we are going to be talking about. Hold on, I'm about to share my slides. Entire screen. So this is what I'm sharing with you. Okay. Oops. Stop sharing. Just give me a minute, guys. I think there's supposed to be music playing so that I get my slide running. I'll be running in the next 2 minutes. Just hold on for me. Okay. Okay. Okay, so no, this is not what I'm supposed to share. Yes, Roland now. Share entire screen. Yes, ladies and gentlemen, welcome to the final session of Microsoft Build After Party. The topic we're going to be talking about is serverless, and we're going to be talking everything. We're going to be dealing with everything. Everything serverless. We're going to be talking about app functions. We're going to go into the console. We're going to go into Azure Portal. We're going to do some nifty, some fun things. You're going to see it for yourself. And if we have enough time, I'm going to use Visual Studio to build a serverless application for you. But I know we don't have enough time. But yeah, let's see how it goes. So, as you all know, my name is Raphael. I'm a certified trainer. I'm a cloud engineer. I've worked with Microsoft for over 3 years. I've used Microsoft every day for my work for over 3 years. Okay, so I work on solutions that require a high availability, low latency, and other fun concepts that we're going to be talking about in this in this event. So yeah, what is serverless? Okay, first of all, when we say serverless is event driven. You know, when they say something is event driven, something has to happen before something happens. Okay, so you put the two together. Oh, you want some? Yeah, there needs to be a fire on the stove. Okay, before your cooking case. Okay, so something like that. Something needs to happen before something happens. So yeah, let's consider some workflows for serverless. Okay, so for workload, for the workflow for serverless, okay, a developer will definitely write this code. Okay, package it as a container image, gets uploaded to the platform, and that code gets associated with an event. Guys, understand it. Okay, so you as a developer, you write your code using your code editor, Visual Studio Code. Yeah, so the code gets associated with an event, and only when that event occurs, that's when your code will run. So that's the basic workflow for serverless. Now, to break down what I've just said, or to hammer the point a little bit, to hammer it home a little bit, serverless computing is the abstraction of servers, infrastructure, operating system. Okay, what does this mean? It means that you want to take the burden of spinning up servers, the burden of spinning up virtual machines, the burden of spinning up operating system from the developer. Okay, so you want the developer to just focus on what he's doing. Okay, let Azure takes care of. Now Azure basically takes care of everything. Okay, so both auto scaling and everything, you are only built for only when you are using. And the good thing, because of the workflow I explained to you, is only when your code is running that you get charged. Isn't that cool? Okay, so let's hold on. Yeah, so some basic use cases for Azure functions. So Azure functions are great for processing of data, integrating of systems, okay, working with Internet of Things, and building of simple APIs and microservices. So you would want to, you want to consider Azure function for tasks like image processing, file maintenance, or tasks that you want to run on a schedule. Can anyone tell me a typical task that you would want to run on a schedule? A typical task that you feel would use this kind of a typical task you feel that would require or use this kind of that will use Azure functions. Yeah, I'm waiting. 1, 2, 3, 4, 5, 6. Okay, so no one answered. You just okay. So he said salary pay. Yes, it's true, because the truth about it is you okay. Let's assume that you spin up infrastructure for your salary payment. Okay, that means that infrastructure is just going to be there. The infrastructure is just going to be there until month end. So most companies start processing payment 25, 26. Okay, so it means that machine for processing salary is just going to be there, and you're going to waste money. But with Azure functions, okay, you are saying that when salary time it reaches, okay, which is that the salary time is the event, okay, the code that the developer has written should run, okay, so that the whole thing gets. So you see that the event is salary payment, okay, salary pay. You are saying whenever salary pay is salary payment time, let the code run. So you see that this helps the owner of that company a lot, because it's only when his code is running that he gets to pay. Okay, someone made mention of another example, video processing. Yes, shutting down. Yes, thank you all of you that made mention. Email notification. Yes, thank you all of you. You made very, very beautiful examples and use cases. So let me continue quickly so that we can finish on time. It's a heavy because we have some demos to work with. So now consider functions. Yeah, for task like you all mentioned. Azure functions support trigger. Why do we say trigger? Remember, I told you that you typically have a developer that developed the code. Okay, you push that code as a container image. You associate that code with a trigger, so that only when something, you associate that code with an event. So that means that you need to add a trigger. So let's say salary, for example. Now, something has to trigger salary for that code to run. Okay, so and it's okay, so the triggers are actually a good way to execute your code and bindings, and it always there are ways to simplify coding for input and output data. Okay, so you can see that Azure function is so good because you can integrate it into a lot of services. You can integrate it into Cosmos DB, your event hub, your event grid, your notification. You can attach it to storage account. So if you have things stored in storage, Azure storage, you want them to use Azure function. So you set the storage as the trigger. So anything time something enters there, okay, the trigger is pushed. your function, your code runs, and that thing. So the good thing about this, okay, guys, like I think I mentioned it earlier. The good thing about it is, let's say you have like 5 events, okay, and 5 events. Okay, let me tell you something about virtual machines in Azure, because you typically host your workload on a virtual machine or a Kubernetes cluster, like Emo and Promise rightly said. But as long as that virtual machine is running, okay, you are paying, because the truth about it is, even if you switch off the virtual machine, so long as there is that IP address that's connected, unless you deallocate the IP, you still be paying money, okay. But the good thing about Azure Function is only when that event is triggered, okay, that you will pay. So it's good for businessmen, okay. So it's good for people that have businesses. No, it's a good money saver for them, because it's only when their code is running that they pay. So let's say the code runs 5 times in a month. You're only paying only the time the code is running. So it's an amazing, and guys, like we saw in the earlier explanations, okay, you do not need to hire a cloud infrastructure guy, to spin up these things for you, because immediately the code is running, all the things that code will need to make sure what you need happens, Azure will automatically spin them up for you. So it is a very good system. So let's move forward. Yeah. So in Azure, when we talk about a serverless, we're basically looking at 2 things. So in Azure, you cannot say serverless without, and you refer only to Azure Function. So when you say serverless, in Azure, you're actually talking about either Azure Function or you're talking about Logic Apps. So let's look and differentiate these 2 and see what they are. So functions and Logic App, they actually enable serverless workloads. Okay, so now you got to know that. So Azure Function is a serverless compute service. Get that right. Serverless compute service. So whatever you need, if your workload has compute requirements, so the one you would choose is definitely Azure Function. So whereas, okay, Logic App provides serverless workflow. Okay, so both can create complex orchestration, and orchestration is a collection of functions or steps called actions in Logic Apps, but they are executed to accomplish a complex task. So let me give you a simple example of a workflow. Okay, so now I want to use let me give you a simple example of a workflow for Logic App. Maybe you'll be able to understand it better. So let's take, for example, let's say you are shipping something from, okay, let's say you use Amazon, for example. All these logistic companies, you know that every single steps, okay, if the thing gets to definitely Amazon, maybe you want to buy from Amazon UK or Amazon, let's say Amazon.com, that's US, okay. The seller will ship it to a destination in the US from, let's say, typically I use Aramex, okay? So Aramex will take it to New York, from New York to Dubai, or London, from London to Lagos to Abuja. So the truth about it is, because it's a logistic company, they made it possible for me to check every single step where my package is at. Okay, so if you need a workflow that is like that, okay, if you need something that gives you that kind of orchestration, okay, your best bet will be Logic App. Okay, so let me not talk too much. Let's move on, because we have a lot to deal with. So for Azure Function, you develop orchestration by writing code. I already explained it to you. Developers write code, blah blah blah, to container image. Then it's get associated with an event. Then there's a trigger that your code runs. Okay, so it uses durable function extension. For Logic App, you create extensions by using GUI and editing configuration file. So Logic App is basically associated with GUI and configuration files and all that. So I hope that it's clear. Let me see if anyone has any question before I move on. Okay, no one has a question, so I'm gonna proceed. Okay, no one has a question. Okay, good. I think just give me a minute. Give me a minute, guys. I need to fix something. A minute. Okay, so I'm back. Sorry for the little. Okay, so let me continue from where I stopped. So let's compare Azure Functions and Logic App. Okay, so we associate. Okay, we're associating Azure Functions with durable functions and logic. So for the development, okay, you are talking about code first. Okay, for Azure Functions, it all works with code, okay, and imperative style. But for Logic App, you are declaring it. So some of us here are from DevOps background, so we know what the declarative and imperative approach is. So when you say imperative, you actually writing codes. So declarative, you are declaring it. So from those of us from Terraform background, you know what it means to declare. Your YAML file, you put them there. That is how they work. So connectivity. So about a dozen for Azure Functions, we have about a dozen inbuilt binding. Okay, so this is actually AZ204 stuff. Okay, so if you want to go deep down into, if you want to write AZ204, these are the kind of things that you're going to meet there. Okay, so we see that there are a lot of bindings and connectivity for there are a lot of bindings for there are a lot of bindings for Azure Function. For Logic Apps, we have enterprise integrations and all that. Then for actions, each activity. So I'm not going to read from the slide. They're all straight like we see. Then, but before I move to the next ones, let's look at the management. So you manage Azure Functions using REST API, and you can also manage Azure Functions using Visual Studio Code. But for Logic App, you have quite more options. Like you have the Azure Portal, you have REST API, you have PowerShell, you have Visual Studio. Okay, so for content extension, Azure Functions can run locally and in the cloud. Okay, so Logic App only run in the cloud. I think this is very, very important. If you're writing AZ204, this will be a typical quiz question. Okay, I should have even asked this. Okay, so yeah, Logic App run only in the cloud. Okay, your Azure Function will run locally or they will run in the cloud. So let's look at hosting plan. Okay, so now when we talk about I want to ask something. Okay, so what type of service is Azure Function? Can someone quickly answer me? What type of service is Azure Function? What type of service is Azure Function? Can someone quickly tell me? Okay, I'm going to count 6 seconds. If no one answers, I'm just going to proceed. So Azure Functions are not infrastructure as a service. Definitely, they're not platform as a service. Okay, so they're not IaaS, they're not SaaS. Okay, so it's okay, so it is. Yeah, it's platform as a service. Thank you very much, Adeni Damilola. So it is not infrastructure as a service. It is not software as a service. It is PaaS, because the platform is allowing you to bring all your code and they'll give you all the things that you need to do. Yeah, function as a service. It can also pass as function as a service. Thank you, Babawale. Yes, let me continue with the slides. Oh, so okay, so when we want to compare the hosting plan, okay, so most of the times when you're using Azure Function, there are three basic plans. Okay, when we're doing demo, you're going to see this from the portal. We have the consumption plan, the premium plan, and the dedicated plan. So most of the time, you'll always use the consumption plan. But because of time, I'm going to move forward. Let's see what each one of them is. So consumption plan is the default plan. Okay, so it scales automatically because we said that it is a platform as a service or function as a service. Like I said, you don't need to do anything. The cloud provider, it does everything for you. It scales everything for you. So this is actually a very, very good plan to use, because once your traffic is, it can scale up, scale down, and all that. So instances are dynamically added or removed based on the incoming number of events. So one typical good use case for this will be, let's assume that you've hit it big. Okay, you've hit it big. You have, let's say you have maybe you have a platform like Conga, okay, and you have, typically we Africans, okay, parents who would want to buy new clothes for kids during Christmas, okay, during Christmas, parents will buy new shoes, new shirts, new trousers, new stuff, okay. So now you have this platform, and you don't want to manage everything, okay. You can use this, you can use Azure function as the customers are increasing. As the customers are increasing, it's dynamically scaling for you, so that you don't have to do all the work by yourself. Okay, so for premium plan, automatically scales based on demand or premium workload, but typical use case would always be consumption plan. Okay, so let's move on because we have a lot of things to do. Okay, so account storage requirement. So the account which blob storage and general purpose are zone redundant, are fitted out from your existing storage account when you create a function app. So the same storage you can use by a function app can also be used by your trigger bindings, okay, to store your application. However, storage intensive operation, you should always use a storage separate account. This is a typical question for exam. Okay, they'll ask you, they will want to confuse you. If you have a storage intensive operation, what should you do? Okay, I think this is also a good question for an interview. So you explain the scenario that is actually better to create a separate storage account, because your binding and trigger will be using that same storage. So if you have an operation that needs a lot of storage, it's always good to create a separate storage account. Okay, so now the hosting in app service. Okay, so I think I'm going to skip this because functions and app service, they are actually almost the same topic. So we have this thing they call always on. If you run on app service plan, you should always enable always on, so that your function can run correctly. So if you are having app service plan, the function run goes idle after some. Okay, so they just like in your mobile phone. Okay, so you'll agree with me that after some time, if you do not set your screen, sometimes your phone will just go blank. So for apps, it's actually when you are in the app doing all these things, okay, you need to set it to always on, so that it does not go idle. Okay, so let's take a look at how you scale your Azure function. So in consumption plan, we saw obviously consumption plan. Yeah, so in scale CPU and memory resources by adding additional instances of function host. So you can see from the right hand side, you need a scale controller to be able to add additional instances. Okay, so Azure function use a component called scale controller to monitor the rate of event. So if a lot of events are coming, just like I mentioned that you are having a Christmas event and you decided to use Azure function, you need to add a scale controller, because just imagine a company like Amazon having millions of customers for their Black Friday event. So they will not actually be able to handle, because their infrastructure might crash. So they will want to use something like this, because as the number of customers are increasing, there's a scale controller to monitor the rates of how people are adding things to the shopping carts. Okay, so yeah, let's move on. Okay, scaling behavior. Scaling can, yeah. So oh yeah, this is actually very, very interesting. So I see that a single app function can scale 200 instances at once. What does this mean? It means that, see, 200. An instance is the machine that's hosting your application. Okay, so ladies and gentlemen, I've been told that my time is up. So I unfortunately have not been able to do a demo. So, but I thank you all for attending. You see that Azure functions are actually very, very good, especially if you don't want to manage your infrastructure by yourself. Okay, you use Azure function because it scale it automatically for you, and you can have a whole 200 instances for every. Yes, thank you, ladies and gentlemen. See you next time. Bye for now.
Thank you so much, Raphael.
No problem.
So it is good to thank you for joining us. It was a wonderful session with you, very expository. And the time is not enough. we just wish we could have more time to, so that you can take your time to dissect this topic very well. So, so for every community members out there, we sincerely appreciate your time. We honor the time that you've spent with us, and we don't take them for granted. So this is not the end of, so this is the end of the Microsoft build, but it is not the end of our study series. So tomorrow we will be having another series, which is going to be focused on open source. So we are going to deep dive into Linux from beginners to advanced, and we are also if you are looking forward to writing your Linux certification, this is what this series is going to be about, right? It is going to be hands-on from beginners to advanced. So this is one of the sessions that you should not miss out. And from next week, we would continue, we will start a new series on Azure developers. So for interested community members who want to deep dive into Azure developers, understanding more Azure services, so this series is meant for you. We have amazing line of speakers waiting to share their knowledge, the numbers of years they've spent in the industry, troubleshooting, deploying solutions, managing solutions across Azure. So this is a session that you should look out for. So we thank you so much for always being there with us. It is a privilege to serve. So thank you so much. Thank you for all our speakers. So let's give kudos to all our amazing speakers. Let's give kudos to everyone that work together to ensure that we have this session. So we sincerely appreciate you guys, Raphael, Tolulope, Imo, Promise, the guys on the background, the graphics team. I forgot. So thank you so much. We see you again. So we've come to the end of the session. So let's look forward for tomorrow's session. If you are not on our platform, you can join us on Meetup. The Azure community is on Meetup, so you can join us on Meetup. We have you can join our LinkedIn page, right? We are there on LinkedIn. We are available on Twitter. So we have a lot of channels that you can reach us for your technical issues. We have people in the community that are willing to share knowledge, assist you with whatever technical problems that you are going through. So yeah, Olumide is our design guy. So everything that we've been doing, all our design, so he has been the one that has been assisting us. So we've come to the end of this session. See you tomorrow. Bye.